Buenos días a todos. Am, Espero que todos se encuentren bien el día de hoy. Estamos por comenzar la presentación, introducción de los nuevos productos DC Controllers de Mounts. Avisarles solamente que tenemos 5 clases diferentes entre el día de hoy y mañana. Quiero agradecer a todas las personas que nos acompañan. Tenemos gente de Brasil, tenemos gente de Colombia, tenemos gente de Costa Rica y, por supuesto, gente de México. Voy a pasarle la presentación al señor David Cash. Él es uno de nuestros especialistas en aplicaciones de DC Controllers y es el que va a estar dirigiendo la presentación. Todo el mundo puede hacer preguntas, pueden usar el chat, pueden hacer su pregunta en inglés o pueden hacer su pregunta en español y con todo gusto las vamos a retomar. Cualquier duda que tengan, la presentación será en inglés, no, sin embargo, estamos aquí para ayudarles también en español con cualquier duda que tengan. Así que pues sin más preámbulo, vamos a pasar con el señor David Cash. Gracias.
Awesome. Thank you, Damien. As he mentioned, the presentation will be here in English for the overall presentation of it. But if you have any specific questions, you can chat those into or put those into the chat. And then you can also go ahead and we will have time at the end to look at those and go over them and answer any questions that you might have. Now, this is the beginning of a more of a 4-class segment. So this very first session is just going to be a generic overview type of presentation, just to kind of introduce you to the concept of error proofing and also a little bit about our new systems that we're going to be taking a look at. So they all revolve around error proofing and what we can do to help better the assembly process for you, for your operators, and to make sure that everything gets done correctly. So if we look at the new products that we are launching here, we have our EC and ECT controller tools. These are our corded version. They are current control as well as transducerized DC control tools. That all kind of falls in line with our robotic and automation series, which is our ADC series. And then we also have our cordless version of our DC tool system, which is our EPT tools. These are wireless transducerized tools. And we're going to take a look at the EC and ECT and the EPT within this presentation series for what we have coming up. So this afternoon, in roughly about an hour or so after we finish with this, we'll begin taking a look at the EC and ECT controller. We'll look at the basics of what the controller is, the setup for that, and then we'll run through the navigation, how you work through the menu system, how the tool is programmed. We'll look at the ability to add functionality through the software that's included with the system. And then in our last class tomorrow, we'll take a look at the focus on the EPT product, again, our cordless DC transducerized system. And so just to kind of start the entire class system, we're going to take a look at our topic of what is error proofing and how can we use it to better ensure that our assemblies are done correctly. And so with error proofing as a concept, what it allows us to do is basically to add a number of conditions that must be met within an assembly process. And so if one of those or more conditions are not met within that particular assembly rundown, then the operator is notified that there has been an error, and then they need to reattempt that particular fastening process. Error proofing can also be done through the use of additional equipment that may be used in conjunction with the assembly process, and that could be the use of maybe a position control arm where the tool is placed into a torque arm that has the ability to monitor the tool in a certain space. And until that particular location within the assembly process, the tool is moved to that location, will we have power to the tool and be able to run that assembly? We can also use other devices such as maybe a bit socket tray that would allow us to be able to select a bit. The controller then would automatically select which preset is being used, or it could be the reverse. We have the controller tell the bit socket tray which bit needs to be used. And so there are a number of different elements that we can use to help guide the operator to make sure that they're doing the assembly process correctly. And so as it comes to our EC, ECT, and also for that matter, the ADC and the EPT series DC tools, we can use that type of programming through a specific rundown to make sure that that is a correct and good fastening for that particular application. And so with that, we can use different tightening strategies. And we have two basic tightening strategies within the use of the DC tools. That's going to be torque control with angle monitoring. And what this does, it allows us to be able to have the controller not only look for a specific torque value and stop when that torque value is achieved. We can also take a look at monitoring the amount of turn or rotation that it takes to fully seat that fastener correctly. And so this can help us in a couple of fastening scenarios where we may see errors. We may see the correct or incorrect set of fastening equipment on the particular fastener. And so one would be if there is a cross thread type of an event. That was going to take place right at the very beginning of the rundown. So when the fastener is cross-threaded, we would certainly hit the torque value because that fastener has stopped and has gotten stuck. However, because we can monitor also the amount of angle or the amount of turn, so typically when we're doing that, we think of angle in the amount of degrees of rotation. So 1 degree of rotation is going to be 360 degrees of angle. So if that particular fastener, say, has 5 revolutions to fully seat, then we know that our angle requirement to fully seat that fastener is 1800 degrees. So with our monitoring the torque, we can also put an angle window that would be acceptable for that particular rundown. So we could set a minimum, say, at 1700 degrees, a maximum at 1900 degrees, and we can then make sure that that fastener meets that additional condition or requirement to get a good rundown. So in that cross-thread event, the torque would be met. However, the angle requirement would not be met. So we would receive a notification that there was an error and the operator would need to reattempt that particular fastening. This can also be useful if there is a possible washer type of stack that needs to be included with that particular fastener in that rundown. And if it's not included, then that's going to change the amount of angle or the amount of available threads that are going to be or allow the fastener to travel further, increasing the amount of angle. So we also have that ability to detect that particular type of an event. And again, the operator would get an error. We would get a over angle error in that case, and that would indicate that they forgot to add additional washers or a gasket, some other type of part of that assembly that would allow the additional angle to be seen within the that particular application. So it's very useful with those particular conditions that need to be met for us to be able to error proof that type of an assembly. Now, one of the other tightening strategies that we have is going to be basically the reverse of that. We can have angle control with torque monitoring. So we can tell the controller for a certain preset to only turn the fastener to, let's say, a target of 1,000 degrees. And we can also monitor how that torque is being monitored during that rundown. So when it finishes, the torque must be between a minimum value and a maximum value. So we can then make sure that that was a good process as well. And so with those two tightening strategies, it makes the system very flexible for us to be able to monitor the assembly process. Another thing that we have within the system is we have about 30 different programmable tolerances that we can use within a particular preset or rundown, and we can monitor those. We can basically craft or use different tolerances within that particular preset to work for that particular fastening application. So for example, if we had a real fine thread type of application where a cross thread event may be advantageous to that, or may cause that quite a bit, we can use things like our free reverse, where we can actually start the fastener in the reverse location, or excuse me, reverse rotation, and to make sure that that fastener will drop down into the thread. We get good engagement, then we can go ahead and start the fastening process. There are a number of different parameters that we can use to make sure that the operator make sure that they run the tool throughout the entire process until we get a good or an error event. One of those types of situations would be we can put what's called a fastening stop error. If the operator lets go of the trigger of the tool before the operation is complete, we would get an error. This is very useful, of course, if we're monitoring the amount of angle within a fastening process, to make sure that if the operator accidentally lets go of the trigger, they start again, we're going to be monitoring the angle from a different starting point then. And so then that would allow us to be able to catch that type of error as well. A lot of some of the other features that we have that can help us in this would be our job and modeling functionality. And this allows us to be able to kind of craft an assembly process for a certain type of build. This would be helpful in a cell type of build, where we may be wanting to use the tool at one preset for a certain number of fastenings, then have the tool automatically switch to a different preset for a certain number of fastenings. And we can craft a job or a model around that particular assembly. And so with the DC tools, we have the ability to have 15 different preset values that we can use. So with a setting in a job model, we can say if there are, say there's 4 different fasteners that, or 4 different fastener presets that we're using for an assembly of a total of 20 different fasteners, and they're each 5 fasteners for each preset. We can tell the system to run at preset 1 for 5 fastenings, then automatically switch to preset 2, run those for 5 fastenings, go to preset 3 for 5 fastenings, and finally finish at preset 4 for 5 fastenings. And so until we get a good rundown for each one of those fasteners, the system won't index or won't count until we get a good particular rundown for that particular item. So within the job and model function, we have the ability to do screw counting for that particular model. And so with our system, we can have 15 different models that we can use that can be made up of the 15 different presets that are available within the tools. So that's another way we can help to error-proof the assembly process. So those jobs and models can be selected either on the display. They can be selected by a preset, a PLC. They can also be selected by a barcode or another input device that we may be able to use. And that allows us to be able to kind of automate the system. And we'll talk a little bit about that more in our other upcoming classes. With the systems as well, we do have the ability to have digital inputs and outputs for these controllers. So we can kind of integrate that into a system. As I mentioned, we can have a PLC communicate with the controller to help a number of different things within the assembly process. So we can select a preset to be used. We can notify the system when a certain part of a job or a model is complete. So we do have that ability to have inputs and outputs to be able to have line and process control within the system. So if there are light trees or light stacks that we want to communicate with, or pneumatic jigs and locks, we can communicate with those as well. And so as an entire system, we can utilize all of these tools that we have available with these different parameters, different tightening strategies, and a number of different ways that we could communicate with the line control to help better error-proof the assembly process. And so with that, that kind of gives us the overview of the items that we're going to be covering. Again, we're going to look at the tools or the controller itself, the ports, the ways we're communicating. We'll look at the menu structure. We'll look at programming, and we'll look at using the software. And again, we're going to be looking at the cordless version as well. So we got a total of 4 classes, 2 this afternoon, or depending on where you are, 2 this morning, and 2 again tomorrow as well. So at this point, if there are any questions that we can help to answer at this point, if it's something that we're going to go into in a future class, I can kind of direct you to that as well. So feel free to go ahead and chat in your questions. If they are in Spanish, that is fine. Damien will be able to help to answer those questions, or I can assist as well. So do we have any questions at this point, Damien?
Good. Dave, I don't see any questions on the chat yet, but I'm going to ask in Spanish. ¿Alguna pregunta, alguno de los asistentes que tenga que quieran que hagamos en este momento? Como indicó Dave Cash, hay 2 sesiones más el día de hoy y 2 sesiones más para el día de mañana. Lo tratamos de quebrar en pequeños segmentos para que no sea muy largo, muy tedioso, presentando los diferentes aspectos de los productos que estamos lanzando. Entonces, si hay alguna pregunta, este es el momento. Igual nos puede mandar un correo electrónico y les podemos contestar. So there's only one chat, just indicating everything is very clear, Dave.
Okay.
And that's the only thing I have.
All right. So in about, it looks like an hour and 10 minutes or so, we're going to be starting the first session where we're going to basically take a look at the physical makeup of the controller. And we'll look at the ports and basic simple menu navigation for the controller. So that's going to be our first class. The second one, we'll look at a little bit more of the programming and some of the other tolerances that that we can use. Tomorrow in our first session, we'll look at the software and some of the workflow type of settings. And then our last class tomorrow, again, is going to be on the wireless transducerized DC tool, our EPT series. So with that, if we don't have any more questions, we invite you to come back for the next session, and we'll see you then.
Hey, Dave. Just so you know, we have a question. I'm going to forward it to you for our next session.
Okay. Damien, are you still there?
Yeah, I'm here. I'm gonna take care of it. I'll answer to Danny. Dani Remoto, ¿estás ahí todavía? Me imagino que sí. Para contestar tu pregunta, sí, estadísticas de proceso, hay una sección en el programa de monitoreo en el que se puede lograr y acomodar las estadísticas de acuerdo a tus necesidades. Puede ser en datos, pueden ser en gráfica, puedes hacer ajustes de las gráficas, puedes hacer un reporte, ya sea que lo grabes en la memoria, viene con una tarjeta de memoria SD o lo puedes transferir directamente por internet o lo puedes bajar por algún medio de alguno de los protocolos que incluyen en este equipo. Jorge Galindo, sí, definitivamente habrá más oportunidad de hacer algunas otras preguntas porque las sesiones van a ir yéndose un poco más al detalle, más al detalle de todo, cada una de las funciones de los equipos. I think we're good, Mr. Cash.
Okay. All right. Thanks again. And we'll see you in our first session. Thanks so much.